Alright, let's see. Let's do this problem right here. I want to show you guys something. We learned this in the notes, but I want to make sure you understand. Notice that with this angle here, we have, use red for the arc. Here's the intercepted arc, and we know that that is 2 times 3x minus 8, which is the inscribed angle that intercepts that arc. And then on this side, we have this inscribed angle, which intercepts this arc over here. And you'll notice, and I'll just name it 2 times 5x plus 2, right? Because that is the inscribed angle that it comes from. Now, we know that those two together, I'll just do this in black, 2 times 5x plus 2 plus 2 times 3x minus 8 equals the whole circle, 360. Now what we can do here is we can pull out that 2 and say 2 times both of these binomials equals 360. Right? And in this case we can divide both sides by 2. When we do that, we get 5x plus 2 plus 3x minus 8, and this doesn't even need to be in parentheses, is equal to 180, because 180 is half of 360. So what you'll notice is that those two angles, opposite angles of these quadrilaterals that are inside of the circle, are supplementary. Okay, so that's reliable. Like right here. You know that 2y plus 3y plus 5, 3y plus 5 plus 2y equals 180. Okay, those are opposite angles, and really we can tell because their endpoints, like right here and right here, are the same. Right, so the sum of those intercepted arcs is 360, and we know that those inscribed angles are half of that. So we know that they add up to 180. So to kind of shortcut this one, let's move this up. Combine like terms, we get -6. And 5x and 3x is 8x equals 180. So add 6 to both sides, we get 8x equals 186. And then x equals 186 divided by 8, which according to this calculator is 23.25. 23.25. Okay, so we found the value of x here. This one we'll finish up. Combine like terms, you get 5y plus 5 equals 180. Subtract 5 from both sides, you get 5y equals 175. So y equals 175 divided by 5, 35. Okay, we got y, but of course we need x and z. So I'll kind of do the same thing. I'll say x plus z equals 180. You'll notice that they share the same endpoints. Look at z, look at x. Okay, which means that when you add them together, you get 180. Okay, and we know x is equal to 1/2 of its intercepted arc, which is 108 plus 75. So x is equal to 1/2 of 183, which is equal to 91.5. So now that we have the value of x, we can plug it in where we have this equation that we know is true. So 91.5 plus z equals 180. Subtract 91.5 from both sides and you end up with z is equal to 88.5. Okay. There we are. And then let's real quick do this problem. So let's look at those angles who share the same endpoints on the circle. For example, z and x. So I know that x plus z equals 180. But I also know that x is equal to 1/2 the sum of its intercepted arc, which is 51 plus 81. So x is equal to 1/2 132, which is equal to 67. No, 66. Okay. So x is equal to 66. Now we can look at those other angles, for example, w and y. I'll just write this out because I know it's true. Maybe it'll help me, maybe it won't. Y plus w equals 180. Now I'll just look at what the value of w is. W is equal to 1/2 its intercepted arc. And its intercepted arc here you can see is 51 plus 79. And when we evaluate that, we get 1/2 of 130. Yeah, 130, which is equal to 65. Okay, and since we have 65 for w, we can plug it back in here. So, did I say 165? 65. 65 plus y equals 180. Now let's take 65 from both sides to keep it balanced, to keep it true. And when we take 65 from 180, we should get 115. So we have y, we have w, we have x, and did we get z? Did I not get z? Z is equal to 180 minus x, right? Subtract x from both sides, you get z is equal to 180 minus x, but we know x is equal to 66, so therefore z is equal to 114.